I'm working as DevRel engineer at Safe, and today I want to share how to build a plugin with the Safe core protocol. So you may or may not know what the Safe core protocol is. It was shared publicly a few months ago. Many new terms and concepts were introduced, like modules, manager, registry, plugin. And now I would like to show you a little bit how what all of this is, and specifically how to build plugins that can extend the functionality of smart accounts. So before going deeper, I would like to share first some issues we have with modular smart accounts that they will fail if there's no interoperability, no discovery, and no security. By interoperability, it means that currently there's a risk of vendor locking, multiple projects working on tools and extensions for smart accounts that are not compatible, creating a fragmented ecosystem. Also, there's duplicate work. We are trying to fix this issue with the Safe core protocol by creating a protocol that is account agnostic and will allow to communicate smart accounts with these extensions. Regarding discovery, there's no central place these days where to discover smart account extensions. So there's an issue for users to discover what kind of extensions they can connect or enable in their accounts to expand their functionality, but also the other way around for the developers of them. And regarding security, there's also an issue where users need to trust every single extension they want to use. So to solve also discovery and security, we are introducing registries that are like curated lists of these components, the modules, where developers can submit their plugins to it, and also users via a manager contract, they can trust this registry and then select the modules or plugins they want to enable in their accounts. So the state of the Safe core protocol today, it is still in an alpha version. It's ready for hacking and playing around with it, but not ready for use in production. So expect changes and things to break. It is designed to be account agnostic, but first we are focusing on the Safe, specifically version 1.x, to speed up the development. It is open source, everything is public, and you can read all the contracts and documentation about that. And also, currently we are looking for community feedback, and now it is the best time to help us evolve this protocol. So before sharing the overview, I would recommend to check before this, or maybe later, another workshop that was presented at ETH New York 2023 on ETHGlobal, where I was showing like a big overview and diagrams more in detail on how the flows on this protocol work. Right now, I will cover that quickly and then share some code examples to actually implement a plugin. But yeah, let's go with the diagrams. So at Safe, we have the Safe account, and then we have different elements that can be plugged into the accounts directly to extend the functionality. For example, modules are able to initiate transactions. Transaction guards are able to parse and check the transactions that are being executed and act on them, maybe reject them if some conditions are not met. And then fallback handlers are able to add extra functions to the core smart account. With the Safe core protocol, what we are doing is removing this the direct connection of all these components and just enable a Safe Protocol manager directly into your account. This manager would have access to a registry where multiple modules are listed. There would be an owner of this registry that is curating this list. And then also the manager would allow to communicate, would allow the communication between the accounts and the modules. And there are different kind of modules like plugins, hooks, function handlers, and so on. Today, we are going to be talking about plugins specifically, the ones that are able to initiate transactions that will be sent to the manager and then to the account. So let's see how to add a plugin to a registry, enable a plugin in an account, and then how to execute a transaction via a plugin. Again, to get more details on this, I recommend checking the other workshop. So to add a plugin to the registry, basically, we can call the function add module in the registry and just add it to the list. This has to be done by the owner, of course. Then if we want to enable a plugin in an account, if we are a user, then we would need to execute a transaction that tells the manager to enable a specific plugin with a specific kind of permission. Then this manager will check if the plugin is added to the registry. We'll ask the plugin what kind of permission does it need, and then the manager will store in the storage, okay, this Safe has enabled this this plugin with this kind of permission. Finally, how are transactions executed via a plugin? Now here the flow starts on the plugin side by calling a function in the plugin, let's say exec. Now the plugin will send this transaction to the manager. Depending on the kind of permission this plugin has, one of these two functions can be executed, execute root access or execute transaction, where we can pass the Safe, where this transaction is going to be executed, and the transaction itself. And this transaction will also have some metadata to give some context to the transaction and tell interfaces who is the plugin initiating them. And we will see more of this later. Then the manager, when it receives the transaction, it will check if the plugin is enabled into the Safe. It will also make sure that the plugin is added to the registry and it can be used correctly. Then the manager will ask the plugin what is the kind of permission it has. We'll make sure, and we will compare with the data that is stored in the manager's storage. And if everything is okay, the manager will finally send the transaction from the plugin to the Safe, so the Safe can execute it. This was very fast, but now we are cover the plugin and the manager sides a bit more in detail. So basically, for all these four components, there are interfaces that anybody can implement and deploy its own manager, its own registry. Today, we are going to see our own plugin. So the interface for a plugin, it's simple, it's small. It has 4 functions: name, version, metadata provider, and requires root access that we need to implement. And then on the manager side, probably we don't need to implement a manager, but we will need to call some functions depending on the permissions the plugin has. We can call execute transaction or execute root access. So let's see some code. Here I have a Visual Studio with some folders, some repos, the Safecore protocol, where you can find the official implementations of the registry and the manager. Also check some interfaces. Then in the specs, you can see some documentation and diagrams and flows. And now we will work with the Safecore protocol demo. This folder has 2 projects inside. One is web and the other is contract. the web is a Safe app that we can see here. This is the Safe web app. I just created a Safe on Girly. And then if we go to app, I added a custom app that is called Safe Core Protocol Demo. And this one, it shows a registry in Girly with multiple plugins that are listed there. So we are going to add one here and enable it in our Safe. So that is the web. And let's open the contracts. Here in the contracts, this is a hard hat repository with some examples that we can see here. Well, I have some tabs open. Also, there are some useful scripts to deploy the plugin we implement, also to add it to a registry. Here, we will be using a registry that is a test registry, so anybody can add anything there just for testing purposes. So let's start with the different plugins. This one. Let's create a very, very simple base test plugin. If you remember, there's an interface that needs to be implemented, the iSafe protocol plugin, where we have a name, a version, requires root access. It can be true or false, and then the metadata provider function. Also, if we want to execute transactions, depending on the permissions the plugin has, we can have, let's say, a test plugin or a test plugin with root access. Very quickly, root access means that transactions, for example, if a plugin has root access, it can execute delegate calls and also transactions where the destination is the Safe or the manager. So kind of admin transactions can be executed because if the destination is the Safe or the manager, maybe the signers of the Safe can be replaced, or maybe new plugins can be enabled or disabled. That is kind of admin permission. Anything else is just not root access. So with a plugin that has not root access, we can implement a function. A function that is called execute from plugin, for example, that receives the manager, where we are going to send our transaction. We need to specify the Safe that will execute it, and also the transaction that the Safe will execute. And then this function can call the manager, specifically the function execute transaction, and pass the Safe and the transaction. If we are talking about a plugin with root access, then this is very similar. We just need to make sure that the variable requires root access is true. And instead of calling the method execute transaction, we can call the one called execute root access. So now we can see talking about metadata, because here when we send a transaction, this Safe root access transaction has some metadata, not just the transaction itself. This metadata can be something similar to this, like a name of the plugin, the version, if it requires root access or not, but also different things like an app URL, where there can be an interface deployed that is able to interact with the plugin if there are some things to be done there on the interface, maybe an icon for the URL or whatever. Now, if we see a very basic implementation of this abstract contract, this is an abstract contract as well, but it has a constructor where we can pass some metadata, and we will store here some things that are required by the interface, like the name, version, and requires root access. And also with the metadata, we are going to encode it, calculate the metadata hash, and store it there for later. Now this metadata can be handled in different ways. There is an enum where we can specify where this metadata will be stored. For example, maybe in IPFS, or maybe in a URL, in an API, or maybe in the contract itself. Or maybe we can emit an event from the plugin that has the metadata and that we can check later in the future. So let's see these two last ones, the contract and the event. So here, for example, if we have a base plugin with a stored metadata, that is also a base plugin, we will have a constructor where we are passing the metadata and encoding it. But also the interface requires to implement the metadata provider function that returns the provider type and the location. The provider type will specify how this metadata is handled in the plugin. In this case, it says contract. And then the location, where to find it. In this case, is in this contract, in the plugin. So the interface will read this information, will know it is stored in the contract, in this contract, and then it can call the retrieve metadata, pass the metadata hash, and receive the encoded metadata in return. So now the interface will be able to display here like the name, the interface, and also a link pointing to the interface where we can interact with the plugin. In case we are using, for example, the events metadata, we can implement this similarly, but differently. We can have a constructor where we are passing the metadata. And here in the constructor, we can emit the metadata event, pass the metadata hash, and the metadata encoded. So later, if the interface calls the metadata provider function, it will receive that the provider type is an event. It will know that the event was triggered by this contract, meaning that the interface will know how to access that metadata. Let's see now a plugin that uses the event metadata. For example, an allow list plugin. What is that? What it does is not relevant, not very relevant for us right now, but basically allows, let's say we have a save with 3 owners, and then we want to interact with Uniswap smart contract to swap 2 tokens, but we want to allow these owners to execute this transaction independently without the need of collecting the signatures from the other signers. Then these owners, or let's say the save, could call the method add to allow list or remove from allow list. And there they can add some destinations where these owners, if they use the plugin, they could interact with directly. In this case, a save could add the Uniswap smart contract to do the swapping. So now this contract is a base plugin with events metadata. This means that in the constructor, the plugin metadata is emitted, and it has a name, it has a version, it defines it requires root access or not, and then it has some other properties. Let's add here some ETHOnline allow list plugin, for example, in version 1, and for the app URL, let's say http example.com. Here, ideally, no, it's mandatory. We will have the URL where we can interact with this plugin. But now that we have this plugin implemented, well, maybe it's interesting how the execution works. Here, it basically this method, this function execute from plugin can be called from an owner of the save, passing the managers, the save, and the transaction, as we saw before in the interface. It will check that it can only be called by an owner. And then it will check because we can pass an array of transactions. It will check that the destinations of these transactions are added to the allow list. And finally, it will call the manager, execute transaction, because it does not have root access, passing the save and the transaction with the nonce and the metadata hash. So now let's deploy this contract on Girly. We need to install the project. We need to build it as well. Okay, and now we can deploy it. Yeah, deploy on Girly. Okay, this will deploy the new plugin in Girly. We will see the address in a bit. Okay, here it is. Now that it's deployed, we want to add it to the registry. In the real world, this would be more bureaucratic, talking with the owner of the registry, meeting the security requirements like auditing it and so on. Here in the test world, we just need to call yarn. There's a script here in this project to add it to the test registry. Register plugin on Girly as well. And now it will go to the interface. Here we see that the plugin is not added yet. Now we see that the registry address is this one. The plugin we are adding to the registry has this name, ETHOnline allow list plugin in this address. And if we refresh the registry here, in the end, we will see that there is a new plugin added to the registry with the name, with the version, and with our URL that was example.com, but can be or must be a proper one. So we can enable it in the save. And if we see this generates a batch transaction with two actions. The first one is enabling a module. This is telling the save account, this one, to enable a module. This address is the manager that we are enabling in the account. And then we are enabling a plugin. So we call the manager, the ABD, which is the same. And we are telling to enable this plugin, the one we just deployed, with no root access. So we can execute it. And when this is ready in the settings, we will see that now the save has a module enabled. Okay, transaction successful. We can go to settings, modules, and now we see that this is the manager. Now that we have the manager enabled and also the plugin enabled, we could use the plugin. We can also enable other plugins like this one, for example, the relay plugin. We see that now there's only one transaction to calling the manager, the ABD, enabling this plugin with no root access that we can execute. So now we can add we can enable in our account all the plugins we see in the registry that we like. Also disable them, of course. Now transaction was successful. And here in the registry, we need to reload it. We see that the relay plugin now offers us the option to disable, but we don't want to disable, we want to use it. So this plugin, one of the metadata properties for the interface is actually pointing to an existing interface where we need one transaction, and this plugin will allow us to relay a transaction, not just execute it with our safe, but a relay will pay the fees for us. So we can create a transaction where we are sending some tokens to ourselves. But we are not executing this, just signing it, making it ready so the relay can later execute it. Okay, now the transaction was added to the queue, and now the interface of this relay plugin sees that there's a transaction ready to be executed, and this interface will allow us to call the plugin and to execute the transaction by relaying it using Gelato relay. So now we just have to wait a little bit. And the transaction will be executed, and also the relay plugin will extract some funds according to the gas costs from the safe and send them to the relay. Takes a little bit, but it will go through at some point. Okay, so now the transaction was relayed using the relay plugin. So now we can see some resources. It's basically the ones I just showed, the safecore protocol and the safecore protocol specs in the ETHGlobal organization in GitHub. If you want to check the demo that I used, is safecore protocol demo in the 5.8, which is an organization more for experimental things we are working on. And then the UI for the registry, you can find it in the last URL. You can contact us on Twitter. We have some docs, Discord, a forum. So thank you very much for attending this workshop. I hope it was useful for you.